In this video, let us continue our discussion on process scheduling algorithm. Round-robin algorithm is one of the most popular scheduling algorithms. This is a preemptive scheduling algorithm. In round-robin scheduling, CPU is allocated to a process for a fixed time interval called quantum. If the process does not finish within that time interval, the process will be relinquished and put to the end of the ready queue. Processes are selected on a first-come, first-served basis. Consider the set of processes P0, P1, P2 and P3 arrived in the order at time 0. Let us see how the processes are scheduled using round-robin algorithm. Assume that the time quantum is 4 milliseconds. The processes are placed in the ready queue in the order of its arrival. First, the CPU is allocated to P0. The burst time of P0 is 10. Since the time quantum is 4 milliseconds, at time 4, P0 is relinquished from the CPU. Since it has 6 milliseconds more to execute, it is placed at the end of the ready queue. Next process P1 is allocated. At time 5, P1 finishes its execution and P2 gets the CPU. At time 7, P2 finishes and CPU is allocated to P3. At time 11, P3 finishes and P0 gets back the CPU. At time 15, P0 is again relinquished from the CPU. Since it has 2 milliseconds more to execute, it is placed back in the ready queue. Since P0 is the only process in the ready queue, CPU is allocated to P0. At time 17, P0 finishes the execution. Let us draw the Gantt chart. P0 starts at time 0 and releases CPU at time 4. P1 starts at 4 and finishes at 5. P2 starts at 5 and finishes at 7. P3 starts at 7 and finishes at 11. P0 resumes its execution at 11 and releases the CPU at 15. P0 again resumes at 15 and finishes at 17 milliseconds. Waiting time for P0 is 7 milliseconds. P1 is 4 milliseconds. P2 is 5 milliseconds and P3 is 7 milliseconds. Hence, the average waiting time is 5.75. Turnaround time for P0 is 17. P1 is 5, P2 is 7 and P3 is 11. Hence, the average turnaround time is 10. Round robin is used extensively in time-shared systems since the use of small time quantum provides good response time. However, short time quantum requires frequent context switching, thereby increasing the overhead. If the time quantum is too large, then the algorithm reduces to first-come, first-served scheme. Next, scheduling is priority scheduling. In priority scheduling, a priority is assigned with each process. The process with the highest priority will get the CPU first. Each priority processes are scheduled in first-come, first-served order. Priority scheduling algorithm can be either preemptive or non-preemptive. If the newly arrived process has a higher priority than the currently running process, the preemptive priority scheduling algorithm preempts the currently running process and allocate the CPU to the new process. On the other hand, newly arrived process has a higher priority than the currently running process. The non-preemptive priority scheduling algorithm allows the currently running process to complete its execution and the new process has to wait for the CPU. Consider the same set of processes arrived at time 0. P0 has priority 3, P1 has priority 1, P2 has priority 2 and P3 has priority 4. The processes are arranged in the ready queue in the order of their priority. P1 has the highest priority, so P1 will get the CPU first. P1 exit at time 1 and P2 will get the CPU. At time 3, P2 finishes and the CPU is allocated to P0. At time 13, P0 finishes and CPU is allotted to P3. At time 17, P3 finishes the execution. This is how non-preemptive priority scheduling works. Let us draw the Gantt chart. P1 starts at 0 and finishes at 1. P2 starts at 1 and finishes at 3. P0 starts at 3 and finishes at 13. P3 starts at 13 and ends at 17. The waiting time for P0 is 3. P1 is 0, P2 is 1 and P3 is 13. Hence, the average waiting time is 4.25. Turnaround time of P0 is 13. P1 is 1, P2 is 3 and P3 is 17. Hence, the average turnaround time is 8.5. Priority scheduling may lead to starvation in which some low priority process need to wait indefinitely for the CPU. A solution to starvation is aging. Aging is a technique of gradually increasing the priority of the process that waits in the system for a long time. Let us discuss the remaining part of the scheduling in the next video.